Okay, guys, so we're going to be looking today at lesson 1.3, and we're going to kind of break this up into three parts. We're going to talk about measures of center in this first video, and then we're going to talk about measures of variability, and then we're going to be talking about another type of graphical representation of in statistics called a box plot, and we're going to focus on specifically like a box and whisker plot. Now, if you guys read the book, hopefully you guys did and took some notes on it. You guys kind of taken some ideas of what the mean is. It's the average. I mean, that's the key word here is that we are looking at the average of the data when we look at the mean. And symbolically, and this will be a formula that I will give you guys, is the way I find the mean is I take the sum of all the values. And if you guys have taken HPC, you guys have seen that symbol. It's just the summation symbol. So it's taking the sum of all the x values and dividing it by the total number. Now, there's two types of mean, and what we are predominantly going to focus on in the first half of the year is what x bar is, and that is the statistic. And a statistic is a number that describes some characteristic of a sample. So like when we look at any data that I'm going to give you guys today, it's not everything in the entire population, because that's impossible for me to look at the entire population. It's just going to be like a sample in some instances. Now, we will talk more about mu starting in chapter 6, when we talk about parameters, and parameters is a characteristic of the overall population. Okay? So let's look at this set of data. So we are looking at a sample from the American Statistical Association. These are looking at the idea of the number of likes that they've had on certain posting. So what we want to do is we want to find the mean of this data. And if you guys remember with the mean, we're finding the sum of all these scores. And I'm going to encourage you guys to try this before I show you what the answer is, okay? To calculate the mean by hand of what it is. And if you add up all these scores together, all 10 of them, you would get 80 over 10. Okay, that would be what the mean is. Now, if I were to take away, in this next set of questions, we are asked to take away 15 and 16 away from this data. So I'm scratching 15 and 16 out. Okay? So then we were asked to find the mean of this set of data without 15 and 16 thrown in. So I do get it to be 49 over 8, or 6.125. Now, if I were to ask you guys to interpret it, which we will talk about, we would say that the average, in this case, the average number of likes of an Instagram post for AmStats is 6.125 likes. That's when we take away those values. Now, what do we notice? Like if I compare that 6.125 to this 8, what do we notice when we look at that? Well, it seems like this number is sizably more, not sizably, but it is more than this number. So how much more is it? Well, it turns out it's like 1.775 likes away. So what I would say is that the mean number of Instagram likes decreased by 1.77 likes when 15 and 16 were removed from the data. Now, what is this telling us then about mean? Well, mean is a very sensitive number. And it's sensitive to like values, extreme values. Now, these values could be outliers, but if I look at any type of skewness, like if I look at a skew right distribution or a skewed left distribution, those are impacting the mean, and we will see more about that in a second, okay? So there's one other measure of center that we want to focus on, and that's the median. It is the exact middle number of a set of data. Some of us, when you'll hear me talk about this more, about the idea that the median is the 50th percentile of data. And we will try to get into that Friday, or we'll start getting into that on Tuesday, just talking about the idea of what percentiles are. Now, the big thing when we look at median is that we do need to arrange the data from smallest to largest. So like we're going to look at the same set of data that we looked at, the same 10 numbers that I came up with before. And I'm going to arrange them from smallest to largest. So if I arrange them from smallest to largest, it's going to go 2, 4, 5, 6, 7, 8, 8, 9, 15, 16. And if you guys remember, you've done this since you were probably in 6th grade. We always take out the first and then we take the last. And then we keep going on until we don't cross anything out or we find the middle. Now, one of the big things that it says is that if I have an even number of data points, which I do here, we're going to have to find the average of those middle two numbers. So I'm going to keep scratching it out. And what happens is I'm left with two numbers. Okay, I'm left with 7 and I'm left with 8. So I have to find out what is in the middle of those. So I'm going to add those two together and divide by 8, and you get 7.5. So we could say like the 50th percentile of likes for Amstats is 7.5 likes. Okay. So, what I'm going to ask you guys to do is I gave you guys 3 graphs. Okay, I gave you, for number 3, I'm going to ask you guys to try to find the mean and the median for each of those sets of data. Okay, so I'm going to ask you guys to pause the video, try to find out what the mean and median is for each set of data, and then we're going to talk about it and just talk about what we notice about where their location is. Okay, so let's look at this first set. So when I look at number 3, I do get the mean to be about 5.94. So the average number of games per World Series was 5.94 games. That was the average or the mean. Now when I looked at the median, I got the median to be about 6 games. So if I look at that location, in this case, my mean and my median are about the same location. Now, this is roughly, and what we'll say is it's not definitely skewed. I'm going to say this is roughly symmetric, okay? Because it roughly makes a U-shaped curve. So when I look at something that's roughly symmetric, my mean and my median are going to be about in the same location when I look at that. All right, so let's look at this other set of data. So you were looking at test scores, okay? One of the things that I do want to make a note of, like anytime that we make a dot plot, we want to label the axis. And any graph that we make, we want to label the axis. Looking at some of your graphs that you guys have given me, we need to make sure that we work on labeling these label what the axes represent. So let's look at this set of data. And what I notice is that the average is 50.3. So 50.3 is like right here. That's your mean. And then your median is further to the right. So in this case, this is skewed left. And what I notice about my mean is that my mean is drawn to that outlier at 41. So that 41 actually makes the mean smaller compared to the median because of that outlier. Now let's look at that other set of data, that final one. Like we're looking at the age at first job. Okay? Now when I look at that mean, I got that mean to be 14.8 years. Okay, so if I look at 14.8, that's about right here. Okay, that's your mean. I'm going to label it as X bar, except this is just a sample. And then this is my median. So when I look at this distribution, it is skewed right. And it's that mean is being impacted by those outliers on the right side. So this is some over-the-top types of ideas, okay? So if the data is roughly symmetric, my mean and median will be similar, be pretty close to each other. if the distribution is skewed, the mean will be pulled in the direction of the outliers. The median won't. So like if I have an outlier, in this case, on this edge right here, when I look at a skewed right distribution, and that's what this example is, that mean is being drawn to that outlier. The median is going to stay in the same location. Okay. Now if I look at a skewed left, I do have an outlier on the left. That mean is being drawn to that. Median is resistant to outliers, but the mean isn't. Because the median is the middle number, it's not easily drawn one way or the other. Okay, the outliers do not impact the median as much. Okay, so let's kind of look at things graphic or like using our calculator to do this. Okay, so what I'm going to ask you guys to do is if you guys take out your calculator, and you guys can pause this video during the course of time. Okay, so what I'm going to do is enter each of these pieces of data into my calculator. Okay? So what I'm going to do is I'm going to press the stat button. You guys see the directions on your piece of paper. So I'm going to press stat. And the first thing that I have to do is press enter on edit. And what I'm going to do is, it's already in here in my case, but I'm going to type in all of these pieces of data into my calculator. Okay? I'm going to type all the values in, and you guys can pause the video once you have that. All 23 pieces of data. Okay? So once I have those pieces of data into my calculator, I press second mode a lot of times just to kind of clear the window. But I'm going to press stat, and I'm going to go to the right on top of calculate. So I'm going to press enter on calculate, and I'm going to go press enter 3 times. So what I see in my calculator is I do see X bar. Remember, X bar represents your mean. My mean is 9.5. And I'm going to keep going down. I'm going to press the down arrow. And I got the median to be 6.1. So what I can say is that the average weight of a pumpkin is 9.5 pounds. And the 50th percentile of a pumpkin weight is, let's see what we got here, 6.1 pounds. Okay, so I'm going to just stop, and we're going to do some variability in a second.